All right, well, welcome everybody. Thank you so much. This is the 21st of January, 2025, and we are Open Research Institute. This is the FPGA Meetup where we talk about FPGA projects. What we do is we talk about what we have done and what we have planned to do. If we need any resources to get what we're doing done, because we have remote labs, some hardware resources, software resources, licenses, and things like that for people to get things done. What we focus on is open source digital radio work, leveraging FPGAs and whatever computing resources are needed to get it done. And then if we have any roadblocks, that's what we do is we get together every week and we say, okay, what's really in the way? What can we do about that? So it's a roundtable discussion. So I'll speak briefly about Aaron, and he's the Open CPI person, and he's made a lot of progress and is really happy with the HDL repository and the stuff there. So looking forward to the next couple of weeks for him. And then, does anybody have any time constraints that they should go first? Okay, maybe he'll catch up with us. And then I think we have, let's see, I see AC. Go ahead and introduce yourself. You have the floor. Tell us who you are, what you're up to, and what your ambitions are.
Can you hear me?
Yes, yes.
Oh, okay. I'm a local ham here in San Diego, KJ6 GYC, and just happened to drop in. I get your Open Research Institute Zoom announcement, but I don't usually have the chance to make them. So I'm just sitting here listening in. I know what an FPGA is, but I wouldn't even know how to go about programming one. so, so I just thought I'd drop in and listen in and see what you guys were up to.
Oh, well, thank you so much for
And
joining us.
first name is Adrian, in case I just go by AC. It's a little shorter.
Oh, very good. Well, welcome, Adrienne, and it's so nice that you're in town. That means that you have the chance to visit our lab and see the equipment in person. So most folks that log in can't do that. So please get in touch and we'll arrange a visit. Yeah, and don't feel bad.
Great.
FPGAs are hard and they are not, I would say, not documented as good as they could be, and it's always an adventure, never a dull moment with field programmable gate arrays. Sometimes we feel like we have no idea what we're doing, and then sometimes we feel very accomplished and happy with what we're doing. So it's a learning curve is can be lumpy and steep. But for those of you following along, field programmable gate array is a really neat bit of hardware. If you're used to computers that run code, so you write the software and it runs on dedicated hardware that only does one thing, but tends to do it well. Things like mathematics or registers shifting around. Field programmable gate arrays, FPGAs, are in a family of hardware that you get to configure. You get to change what the hardware does by describing what you want it to do in software. And you can imagine that having such flexibility and power opens up lots of ways to have errors and bugs and strange things happen to you. Now, in the end, once you kind of put your back into it and you get it all sorted out, you can do some amazing stuff. You can implement hardware and make things happen that you would never be able to do with dedicated computing hardware. So that's what we're trying to do and also trying to bring this to open source. There is not a lot of open source FPGA work published. This is sad because there's just such an amazing amount of stuff that's going on. So that's what we're after here. Um, all right. So yeah, thank you. You please consider yourself welcome to come to any of these meetings, and really appreciate your participation and membership. All right, Ken, I think I see you back, and I'm going to hand it.
Yeah, sorry about that. I sometimes have trouble navigating this iPhone version of Zoom. But yeah, I did work a little bit on this yesterday, trying to get the environment back up with the Linux flow. We kind of several months ago switched towards getting the no OS version of the build going, and ran into some issues there with the PLLs locking and so forth. So we may go back to that because I'm not sure. On the Xilinx forums, they say that that's shouldn't be a problem. Although we weren't able to get the tools to like go all the way through the flow because of that error. So I don't know that it's insurmountable, but anyway, Michelle was pointing towards a new initiative to steer away from Petalinux, but still it's a Linux based environment. So I will endeavor to at least just try and get the old Petalinux builds working again, and then we can shift over to the new environment. So that's what I'm trying to do right now, and should have written more of this down, but I'm it's starting to come back to me, and yeah, trying to basically make sure that the build works with. I know that the environment that we have from analog devices, I basically tried to insert our block, making it look like another analog devices block. So I confirmed it's down in there, and been trying to just rebuild, seeing what it takes to rebuild that and get it to be recognized as part of the flow. So that's I kind of kicked off a build overnight. You haven't had a chance to check on it yet this morning though, so I will when I get home. So that's my status.
All right, thanks so much. Yeah, there's a lot of moving parts here. So what Ken's working on is the receiver side on the spacecraft or ground sat for terrestrial deployment. So for our particular system, we have um, what you can consider to be like user terminals, individual handsets, individual radios, and then it's uh, frequency division, multiple access, meaning everybody has their own frequency channel uplink, and the receiver on the receiver side of the central node is what Ken is working on, and that is done by a multi-rate or polyphase channelizer, which tested out good, and we've got a good handle on first implementation, setting up the number of channels and setting up how it works, and kind of understanding the resources required, stitching that work into the reference design from Analog Devices for their large, kind of beefy radio chip, and a substantial enough FPGA has been more challenging than we expected. We thought this would be more of the easier work. So that's what he's talking about. Talks about no OS. That means no operating system. That means it's almost close to a bare metal design. Petalinux is a pretty full featured, for embedded Linux version, but Petalinux, we've been told, is not going to be supported as well as it has been in the past by Xilinx. And the third way of doing this is to use Yocto. And we do have a recipe for Yocto, and we've tried it out since our last meeting. That was one of the action items. And we have some issues with our version of Ubuntu, I think, in the remote lab. So with a slightly older version of Ubuntu, the recipe from Phil Ballister didn't quite complete. So in step 4, it decides that it doesn't like the default version of Python 3, which is slightly older than required, and efforts to get that to kind of get updated. That's where we're at right now. So we'll have a lot more about that on Slack. So it may be that this is we just don't know the command line incantation for this, or it may be that we need to go ahead and move, like we talked about last week with Aaron, was 1804 Ubuntu is a little old. A lot of people think it's too old to do this sort of work. It was an excellent, excellent compromise. It's worked for us for a while, but more and more challenges with trying to experiment, trying to implement things, trying to build versions of embedded Linux for the systems that we're using. So the more times that we come across these problems, that's just another reason to consider going ahead and updating the operating system. So that's the sort of the summary as of right now. And I'm going to hand it over to Paul to correct me or to expand on the things that I've just talked about, because he was there to see the efforts to try to build pure Yocto versus Petalinux.
Yeah, I have no corrections. There are a few expanded things I could mention. There's seems to be a mechanism for doing this, for using versions of the operating system that do not contain the tools needed to proceed that are built into the Yocto system. I found a reference manual that talks about it. I don't yet know exactly how to proceed, but I'm confident that there's a way to proceed without updating the OS. Um, that doesn't mean that we shouldn't be looking toward an updated version of the OS. I'm afraid that if we just went ahead and updated ChocoCat, though, that we'd end up with a version that only did the new things and couldn't do all the old tricks. Um, One of the nice things about having virtual machines is that you can, set them aside and have another one without a huge cost. So I'd be feel more confident leaving ChocoCat undisturbed and switching to one of the other VMs with a more modern OS for this project. Um, this little sub project anyway. That this is especially true until such a time as we have a better facility for snapshotting and rolling back VMs, which will be a side effect of switching to the new version of the host operating system on RAID, which I talked about last week and have made no progress on since then. So I have nothing new to report about that.
Okay, well, that sounds like it might be a good long-term thing to kind of migrate towards, is to allow us to have more flexibility on the VMs to answer these exact sorts of questions. And I realized that I did not define what Yocto, it's Yocto, the Yocto project, and I put this in the chat. It's an open source collaboration. It's a project that helps developers like us create custom Linux systems, and it's supposed to be hardware independent. And the Yocto layers are what's invoked by Petalinux in order to create the Linux systems, or OSs that we've been running on our FPGA development boards. So we've already been using it, but we've been kind of like encapsulating it in a lot of other mechanisms that were maintained by Xilinx, the company that also makes our dev boards. So, in one way of looking at this, we're like, we need to take more ownership of the embedded Linux that we're running, and the eventual outcome will be higher quality and more supported embedded Linux. But that also means discussions like the one we're having about the OS versions in our lab and the ability to switch and between them. That's all very important. One of the really nice things about our lab is that we have a server that supports a lot of different types of VMs, the Unraid server. Um, and the really nice thing about that, about having a dedicated computer that can allow you to have a bunch of VMs, is that you can then attach hardware to a particular VM. That's always been kind of the problem with virtual machines, is dealing with hardware. So if you have a virtual machine that's dedicated to a set of hardware, to like a dev board or a SDR, then you remove a lot of the trouble. Unraid makes that very possible. So stay tuned. I think we'll be discussing how to move forward. We've seen lots of evolution across the board, and since what we're doing has a lot of moving parts, that once the majority of those moving parts kind of like need uh, a higher or more recent version of the OS, then we don't really have much choice but to move. And setting up a new one rather than trying to update an existing one is legit. So we should be able to have more to report by next week. Does that capture it pretty good?
I believe so.
Okay. Yeah, I really appreciate all of your help and expertise here. It's not an easy job to make this stuff work and cooperate, and work for the people that are giving their time. All right, so I'll give the floor over to Matthew to give us a update from his end, and you have the floor.
All right, thank you. Been pretty busy with some other stuff this last week, so I didn't get very far on various things. So my as I'm looking forward, we have or I we have now the power detector that it's not checked into GitHub yet, but that can be done soon. But integrating that into the MSK modem will be the next project. And then there's, I think, some improvements that we can make to it. So there, I mean, it should work as is, but I think there's some things we can do to improve it further. And then the next thing I'm looking at currently to get IQ outputs to allow the image cancellation. I'm just so this works pretty well. I may not change it, but I'm modulating both the sine and cosine wave with the data, and then putting the sine wave out on Q and the cosine on I. And so in the simulations, we do see the image rejection. So that's working as we would hope. There's a couple of things we can do with that then is, you can potentially put two modems and double your throughput if you wanted and not, have any wider, the spectral efficiency doesn't, or occupancy doesn't go up, but we double the data rate. So that's one possibility. The other is to, instead of doing it that way, create a complex filter that would put out INQs independently. I'm not sure that there's much advantage to that. It's just maybe something to experiment with. But since it's kind of working pretty well as it is, my main focus would be to integrate the power detector. And I think I had some other ideas, but they kind of escaped my mind at the moment. So I mean, I think there's some things we can look at in filtering, but the main thing then would be trying to understand and fix the Pluto to Pluto transmission, where it's not, works fine with analog loopback, but it's not working going from one Pluto to another. And so that feels a lot like some sort of frequency offset issue, which you would get between two devices like that. It's not clear to me why that should be happening, but it does feel like what's happening. I'm getting some more hardware in just so I can, put a little more hands on with some of these things to play with it. But, so that's on its way, or some of it's here. So that'll be something to work on. And I know, Michelle, you've been looking at that, and Paul. So I'm, hopefully we can get that cleared up pretty soon, because that'll make way for a lot more. That'll put us a long way towards the project being viable, a minimum viable product, as it were. So I'm excited about that. I think we should be able to make some good progress. And then I think there's, looking forward a little bit. You talked about the iterative receivers. I've been looking at a number of other receiver architectures that we could play with. There's a lot we can do there in the receivers, I think, that could be interesting and maybe simpler and maybe even more robust. I'm not sure. Like right now, the receiver is going to take the current receiver is going to take some amount of time to synchronize because it's a coherent receiver. So the loop has to lock before you can really demodulate data well. So I think, maybe, I think we want to look at a non-coherent receiver. They typically, generally they won't track as well. They might have a higher threshold, but they can decode without actually having to synchronize. So I think there'll be some good opportunity, I think, to experiment with various receiver architectures. That's looking, forward a little bit, but I'm hoping we can get the current design working well between devices. And then the other thing that I've been looking at a little bit, there's a lot to go through, but just looking at some of the AI technologies, and one of the first things we were talking about is just RTL generation, but there's a lot of papers especially on the pre-pub on the archive, discussing various AI technologies related to radios and EDA. And so in terms of EDA, there's a lot like, if you're doing high level synthesis using AI technologies to predict and do design space exploration. It's not just RTL generation, but predicting timing once you do placement routes, so that helps with the design space exploration and generating the proper pragmas for a high level synthesis. So there's interesting stuff there, as well as there is also a lot in terms of radio stuff itself, like even FEC decoding using AI to assist with FEC. So I think there's a lot of interesting stuff that we can look forward to and start seeing if there's how those might work in a practical real life type products. So I'm kind of looking forward to that. That's certainly not near term or longer term kind of thinking that might be interesting to start looking at those things. But in the near term, in terms of their RTL generation, I still digging through papers and haven't made a ton of progress on that. But hopefully, I think next week we should have should be a good and interesting discussion. I might help focus in on that with the other folks that will be joining. And then lastly, one of the things that was really, we've as we've been talking over the months that we've been doing the MSK now, bit widths come up a lot in the fixed point math, and I'm not a system analyst or system analyst by training, more I've been on the implementation side in architecture, but not really doing the analysis of system implement or system designs, right? And so this has been nice, to get more exposure into that part of the design process. But up until a few weeks ago, it's like I'll just throw bits at it, and bit widths weren't necessarily optimized. And so I've been working through getting bit widths better optimized. It was actually pretty critical for the exponential moving average filter that's part of the power detector. So because you have to get the bit widths right, and you're limited by the DSP slices in the Xilinx part in terms of the multiplier bit widths and that sort of thing. So that I think we can generalize that. I'm hoping to contribute something to the newsletter for that, and then we can go back and review the bit widths throughout the MSK design. I think that'll be useful as well. So that'll be something on the near to medium term as well, just to make sure we have good bit widths throughout the design. So it's kind of my update, kind of a hodgepodge.
Yeah, no, that's a lot. Thank you so much. This is such great work. So yes, a week from today, the slot will be talking about AI ML and what it brings to EDA, to design, electronic design, and automation of that. And so we're going to have a roundtable discussion and spreading the word. It's cross-listed with IEEE and is getting some traction with the various chapters and societies. So hopefully we will have some good speakers. And I think by then we'll probably be able to at least say, like, if we've looked for literature and looked for some papers, and here's where it looks like there's some existing work. So it should be a good first step into this to have a meeting on that. So yeah, look for that. I'll put out the link again in all of our usual channels for that. And when we were talking about like comparing and contrasting different ways of receiving, modulating or demodulating, decoding, the way that we can do that is something that Matthew spearheaded and has enabled, and this is to have a sort of a modem module approach. And the way that we do this is that we have tried very hard to set up the implementation. Our first implementation target is on the Pluto SDR. But it's not a monolithic design. So we've tried to keep the different components of the transceiver um, in a way that they can be kind of separated and where it makes the most sort of natural sense. And this is going to really pay off. This took some work up front uh, and was maybe not, it looks a little more messy than it would if this was a monolithic design, but it will allow us to take a part out and then put a new part in and then to make a comparison between like, okay, here's a working transceiver. What if we change this or that? And also it lets us truly say that we have reusable modular design. So we're doing our absolute best to make sure that that happens, and that will allow us to do the things we're talking about, to try different sorts of architectures or different algorithms, different ways of managing the digital radio. So I think it will pay off. Well, you have to it takes constant maintenance and review. It's an iterative process, but definitely paying off. And we already know because we have feedback from some of the modules that we've published. So there's a sub modules. If you use GitHub or Git, the way that we do it is we have a number of sub modules and we put them together. And if you can think of it like Legos, that's the goal is to be able to put together a radio from different modules. So we get some good feedback. People find this useful, and there's a lot of interest in the two things that are coming. A way of measuring power, so power measurement, um, and then the other is to have a complex modulation, so complex versus real. So those two things have gotten some interest. So yeah, lots of stuff happening, lots of things coming in the near and I think Matthew talked about like there's some things that are in the near future, some things that we have to take care of right now. Uh, what he brought up is our current situation, which is that the digital loopback, without using any of uh, without using the antenna, without using any radiating elements. So digital loopback, just a pure logic loopback works, and very happy about that. And then RF loopback, so out the transmitter antenna port, looped back directly to the receiver antenna port. So an RF loopback works, but going over the air, the only thing that we can say is working so far is the clock recovery, and that we're getting really very high error rates that we haven't quite figured out yet. So that's still the case today. And once we solve the problem with the errors, then we'll have an actual over-the-air system, so over-the-air radio, and that's where we're at today. Yeah, that's an amazing amount of stuff. Thank you so much for everybody here today. This is very exciting work, and I think just I think I can speak for everybody that we've learned a lot. There's a lot to learn about radio, and bringing this to an open source design is such a joy, a hard work, but a true joy. All right, any last comments or questions before we close for the day?
Yeah, this is Adrian. Wow, I'm kind of glad to hear you guys are implementing your project on a Pluto. I happen to own one, so I'm looking forward for you to finalize the project where a dummy like me can just load it up and use it. So I understand this would be for satcoms mainly,
Um,
or also terrestrial type communications.
Yeah, both and. So this is
Okay.
very appropriate communications for space for a couple of reasons. And yes, it's intended to be, this particular design is intended to be a really nice, solid, high fidelity voice link for SATCOM that also incorporates data like files, keyboard chat, and authentication, authorization, or control messages to where you don't have to switch to different modes. So that's kind of our goal with this from a protocol point of view. However, this transmission receiving, this transceiver, is also totally useful for terrestrial. So it's not exclusively SATCOM intended. And yeah, we targeting the Pluto just seemed kind of like a good common since first thing because this are available. You can buy this SDR, load our firmware. It's I think it's literally one line if you have the file that you can update your Pluto. And that's what we really want is to as soon as possible get it into the hands of as many people as possible so they can enjoy it um, and and then let us know like what to do next. So that we're
And one comment on that, just if I
sure.
may.
Yeah, go ahead.
Um, yeah, GSM or MSK is kind of the basis of GSM. It's a Gaussian modified MSK waveform, but so it certainly is already used largely terrestrially, even in mobile networks.
I see. Actually, I have one question regarding the Pluto. I'm not sure since you guys are working with them. I have a question regarding the clock stability or the for the Pluto, and that seems to be a bit of a drawback on that system for some applications and some of the applications I'm interested in. So I'm just curious. I know there have been people that have been able to modify to a higher stability clock, and have any has anyone here done any of those type of mods, or just kind of curious? And if so, what was required?
Yes, I think I'll let Paul speak to that because he was most directly involved with those.
Well, we have not modified any of our Plutos for higher precision clocks. Um, there are two possible approaches you could do on that. One would be to replace the oscillator with a better one, which gets you some incremental improvement. The other would be to set it up for an external clock input and then use a reference clock. We do have a reference clock source in the lab, GPS locked uh, oscillator, which is good to some ridiculous amount of precision, which is handy for measurement, but we've not tried to move it into the Pluto. That would sort of subvert the goal of having the Pluto be a user accessible uh, device that would run the software. So better to have the software be robust and work in the presence of small frequency errors than to rely on improving the Pluto. That's my view anyway.
If
We
I
have,
may add a
go ahead, Matthew.
comment as well. Uh, so I got the parts. I was going to update my Pluto. I just haven't had a chance yet. So I'll report on that at some point in the future when I get that implemented. But I did, interestingly, just order a Pluto. I think they're knockoffs, but they look just like the original boards from AliExpress. So it's actually in shipment. So I was going to play with that. But they advertise it as having a very high fidelity TCXO on it. So if you get one from China, they're a little cheaper, and depending on the quality overall, but you can get them with the higher, um, lower offset or drifting TCXOs from that source.
Yeah, I've seen those advertised on Ali and so forth. I was just curious. Because I had seen some earlier mod possibilities, and I think there was a particular clock that was being referenced, but as I understand, that particular clock module is not available anymore. So I'm not sure if that was something that was
Yeah, I
superseded
think
or
you could get different ones, but they're not footprint compatible. So you end up having to
okay.
kind of debug it. I think I'm trying to remember. I have the instructions somewhere. I haven't looked at them in a few weeks, but I think you have to debug it and then just put a couple of wires to the pads, something like that. So yeah, there's not a footprint compatible replacement that I'm aware of, but I haven't looked deeply. But the information I received was a particular part which I got, and I'll just, like I said, I'll put it on here at some point and give a report once I get that done.
Boy, that'd be great to yeah. Well, yeah, that's fantastic. Like I said, that I can understand your philosophy then, an off the shelf type of Pluto being compatible with the system would make it certainly much more usable for probably the majority of people. So
Yeah,
just curious.
and the MSK modem might should be less sensitive to the frequency offset. It's designed to allow some amount of frequency offset. We haven't characterized how much yet, and it's also designed to track frequency offset. So if you had a oscillator that was drifting, that should be okay with this particular modem, or at least that's when it's fully working and validated, it'll do that because it's one of the things that it needs to do for space applications or rocket applications would be track out uh, Doppler shifts. And so, that would be a form of frequency offset but changing frequency offset over time. And so the current design is intended to track those types of moving offsets as well. So it should be fairly robust for that compared to maybe some other applications.
Well, actually, you just hit the nail on the head as to my concern regarding the frequency stability of the Pluto. I'm avidly interested in radio astronomy, which is kind of an obtuse hobby. And one of my projects is the detection of the neutral hydrogen emission line at 21 centimeters. And one of the things you can do with that is to track the Doppler shift of the hydrogen emission and get some velocity readings of that of the different hydrogen emissions from some of the galactic arms, and so that was my requirement for utilize if I were to utilize the Pluto. There are other SDRs that have better stability, which are the ones that I plan on using. But in any case, that was the reason for my question regarding the Pluto stability. It's nice to have that frequency range on it that some of the other SDRs don't have, but that was the application that I had in mind where I would require slightly better frequency stability from the system. So anyway, but yeah, anything you report back would be fantastic in terms of the potential modifications for it. So that'd be great. Yeah.
Paul, have you looked at using the external clock? That might be even a better choice for the for your application AC. I haven't looked at the schematics recently. Is there a reference clock input? I assume it's not populated on the Pluto board, but do you know that there is one?
I have not looked into it in detail. No, I believe that there is an input on the device, but how easy it is to get at on the board, I do not know yet.
I think
Okay.
it also depends on the version. So some of the versions of Pluto, the external reference has more parts than others. But yeah, it's possible. And having a really rock solid reference is good. And then another way of dealing with it is that you can actually program in a frequency offset. So if you have a stable frequency offset, and they all do, then you determine that, and then there's a command line that you set an environment variable that allows you to get it closer to ideal. And then from there, you can then work on like, oh, okay, is this good enough from here? Do I really need to go in and do surgery on my Pluto? If the answer is yes, then you can go ahead and do it from there, and you're already dialed in. You've already gotten the gross offset, as you don't have to worry about too much Doppler. Then that's kind of the way to do it. So there's several ways to fix it and address it. It's really not too bad off the shelf for the sorts of things that we're doing. So our regardless of any hardware improvements that you can make or that we can make with either our custom hardware or the hardware that we target, we're doing the very best that we can to make this the design, the software, to accommodate and track in the most intelligent way that we can, whether that's adaptive uh, methods, or precision, putting lots of precision into the software. That's our goal. So in between all of these things, I think we'll be able to deliver a really good result.
Oh, great. Well, fantastic. Nice hearing it. And I'll definitely try to see if I can participate in more of the meetings and pick up more in your updates. So kind of looking forward to that.
Oh yeah,
Fantastic.
well, welcome. We're super happy to have you, and yeah, just appreciate your time, and looking forward to hearing how your projects go. We love hearing about amateur astronomy, and there's a lot of overlap in what we're doing and what we're trying to accomplish. And if there is a project that you want to share, talk about, or present at some point, then please consider yourself welcome. We're very interested in hearing about your work.
Great. Well, right now I'm just trying to work on the sort of a not too difficult sort of receiver and antenna projects at 21 centimeters, which 1420 megahertz. I'm also interested in detecting some of the masers, some of the astronomical masers, and I've actually had an opportunity to utilize there's a 20-meter radio telescope at Green Bank that's available for use, and I'm a member of Society of American Amateur Radio Astronomy. Sarah has access to a 20-meter radio telescope, and I've been able to do some scans of some of the hydroxyl masers, which are slightly above the that 21 centimeter, around 1600 megahertz from the Orion Cloud Nebula, which is I've been able to do a scan of some of those in uh, using the 20 meter GBT. And so that's kind of an interesting possibility for accessing a large aperture parabolic dish, which wouldn't necessarily fit in my backyard. So,
So AC, you may be interested also in the Deep Space Exploration Society. They have a was
I'm
it
aware
60
of them.
foot dish?
Yeah, I'm aware. I'm not a member,
Okay.
but yeah, but I've heard of them, right?
But they've
Yeah,
been doing some
they can
pulsar
transmit.
detection recently.
They can transmit also, which I know they've
Yeah,
done a lot of
they do
moonbound
EMA
stuff.
contests
Yeah,
in the when in EMA contesting season, they'll fit the dish with the EME feed. But then they do radio astronomy the rest of the year, and I think they've been doing some pulsar detection recently.
right, right. Yeah, that's yeah. Their dish is certainly at the point. You can just barely get some of the brighter pulsars with something like a couple of meters dish at home, but requires a bit of integrations and so forth. But
There is a guy uses a very highly, it's like a 20 or 30 element directional Yagi, and he's done pulsar measurements with that as well.
there are some, yeah, I've seen some of that work done. Um, Using the Yagi, which is kind of a possibility also at the frequent at some of the lower frequencies of the pulsars. So that kind of seems to work also. But
Yeah.
in any case, didn't want to get off on this other subject, considering the Zoom subject matter here. But but when you mentioned the Pluto, that was the hardware that you guys were focusing on. Well, that perked up my attention since although mine's an earlier model, so I know what you were referencing, Michelle, about possibly not having sort of external clock input available for that, a possibility. I do have a 10 megahertz cesium standard, which uh, which I guess would be pretty stable, not having a GPS lock type system, but so I could probably utilize that 10 megahertz reference signal if I could figure out how to do that. But in any case, well, thanks a lot for the tips and advice, and certainly looking forward for some of the progress on your work.
Awesome.
Fantastic. Nice talking to you all.
Yeah, very, very good to meet you. And just a plug for Sarah, SARA. In the past, we've done some collaboration to help do mutual kind of presentations and forums. I think the last one that we did was at Hamvention, where SARA has had a booth in the past, and when we did a collaborative forum to kind of talk about the shared aspects of work, leveraging things like GNU Radio and other open source digital radio work in order to further aims and purposes of Sarah. And just speaking up for the organization, they have a I think two events a year. There's like a annual symposium proceedings, lots of really interesting work, and a big fraction of it overlaps with things that are of great interest to ORI. So, yeah, really nice to meet you, and I hope to hear more over the next couple of weeks about how it goes. We'll do our best to kind of like summarize the ways to make the Pluto a little more accurate in terms of time. That's a very we get questions about that routinely. So. Well, thanks so much, everybody. Okay, last call for comments or questions. Looking forward to next week. We'll be talking about AI/ML in this particular slot. Hoping to bring. Oh, go ahead, Paul.
This is a Rev C Pluto. I took the lid off just so I could look. There's a couple of these UFL ultra tiny clip-on connectors. One of them is the external clock input. So with a Rev C, it's just a matter of plugging it in with an adapter cable and putting another hole through your blue plastic chassis if you want to use that. On the Rev B, I think you have to actually solder some stuff onto the board to make that work. But it's all documented.
Cool.
Yeah,
Yeah.
mine might be a
UFL's
B
my
version.
favorite connector. Oh, sorry. Go ahead, AC.
Oh, I was just saying. I think, like I said, mine was an earlier version, so I can't recall the exact model, but I assume it's probably a B. It's not probably a C. So kind of heat up the old soldering gun.
Yeah.
Okay, great.
There it
Oh,
is.
it's beautiful. Oh, I see.
That's
That
Yeah,
one
where
right
you're
there
pointing
next
to
to
it
the.
on the C. Well, maybe it's time for an upgrade, or perhaps getting the one of the ones that Matthew was referring to. I believe those also have the instead of just having the single transmit and receive loop, they have a dual system, if I'm not
Well, even
mistaken.
on the base Pluto, there's a second TX and RX. It doesn't come out, but there's UFL connectors. I don't think they're soldered on, at least not the one I have. It depends on maybe the schematic, but
Here on
there
the
is
Rev
the
2.
second TX and RX on the UFLs
Oh,
in
okay,
on the board.
and that's on the C
Yeah,
model, right?
it's TX and RX here on C. They have the UFL connector installed.
Yeah, yeah. Okay, well, that's nice to know. I didn't realize that. But anyway, fantastic. Great. Thanks a lot.
You bet. All right, everybody. Thank you so much. Your time is deeply appreciated, and we'll reconvene back on Slack over the next week. We'll meet back at this time slot next week to talk about artificial intelligence and machine learning. And yeah, just thank you, everybody. See you soon.